Okay, let's give you guys some more practice. So here, let's pretend I'm trying to design a trough here. So I would then fill up this trough with water here. The question is, how should I design this to maximize the amount of water that I can fill up? So the conditions are this length here, which is this length here. This length here must be 1. This here must also be 1. And this length here must also be 1. Okay, so you can vary the angle here. You can vary theta here. What must theta be in order to maximize the amount of water that I can fill up? Okay, so looking at this here, you could make theta to be very, very big here. So theta here, you can make it very, very big. But hopefully you can see, going on your instinct, well, going on my instinct, hopefully you can see that this is a bigger area than this. You see, if you make theta to be too large, then the amount of water that you can fill up here will be less than up here. Well, anyway, the question here is, what must theta be in order to maximize the amount of water that you can fill up? Remember, I don't always have to give you the length L here. I don't always have to give you the volume. If you want V, then create the variable yourself. If you want the length here, then create the variable yourself. Okay, but the question is, what must theta be in order to maximize the amount of water that I can fill up? Okay, that's a question. If you want V, then set up V yourself. If you want L, then set up L yourself. The question is simply, what must theta be in order to maximize the amount of water? Okay, so press pause and have a go. Okay, so here to do this here, we well, if you look at this here, the question is to maximize the volume. Okay, but then instead of looking at the volume, we can just look at the area, because if you maximize the area, then you will automatically maximize the volume. So we can forget about the V, we can forget about the L, and just concentrate on maximizing the area, the cross section, the area of cross section here. If you maximize the area of the cross section, then you automatically maximize the volume. Okay, so we translate. So the question was maximize the volume, but then translate the volume into this area. So now we're going to try and solve the area rather than solving the volume. Okay, so we're going to try and maximize the area here. Okay, so hang on. To do this here, if you look at the diagram here, this length here must be, well, the height here must, well, the height here is given by cos theta. Okay, and hang on, let me think. The width here is given by sine theta. Okay, so you've got, so this area plus this area here is given by this. Okay, and this rectangle here, this area here is given by h times 1. So h is cos, so cos times 1. So which is just cos. So anyway, the area, well, looking at this here, the total area would be given by this. Okay, and don't forget our domain is in between. Well, our domain can be 0. Okay, but it can't be pi over 2. It can't be 90 degrees, if you like. We've got to use radians. Well, it can't be pi over 2. It has to be strictly less than pi over 2, because if you make theta to be 90 degrees or pi over 2, then you can't hold any water. It will just spill out. Okay, so it has to be strictly less than 90. Sorry, strictly less than pi over 2. Okay, so this is our total area here. Okay, so hang on. So this is our area here. So now differentiate it. So looking at this here, differentiate it. So differentiate this will give you this, and then now you've got to use the product rule here, because you've got one thing times another thing. So the product rule is differentiate this, leave this the same. So when you differentiate this, it will give you this. Leave this the same, gives you this. And then the second part of the product rule is to keep this the same, and then differentiate this. That will then give you this. Okay, so tidy this up. That will then give you this. Okay, so now it's just a matter of you trying to solve solve this equals 0. So set this to be 0. Okay. Now up to this stage here, you can use whichever method you want in order to solve theta. Yeah. So your job here is now to solve this. You can use whichever method you want, but in the next video I will show you one method that you can use to solve it. But you can use whichever method you want. Just find theta in such a way that this whole thing here equals 0. Okay. So we will continue in the next video.